In the next lesson, you're going to learn about direct variation. Direct variation is a linear function. And what is a linear function? Any function in which it forms a line on the graph. So it's a linear function that takes the form y equals kx. K, the coefficient, can't equal 0. Okay? So direct variation is a linear function, y equals kx, where k does not equal 0. So if we look here, we have y equals 18x. This is an example of a direct variation equation. The value of y is always 18 times the value of x. It's a constant variation, 18. If we look over here, we have y equals 18x plus 7. This is not an example of direct variation. Direct variation can only take the form y equals k of x. Why? Because y equals 18 times x is constant. So for example, if the value of x was 1, then y equals 18. If the value of x is 2, then y equals 36. You're always at a multiple of 18. However, if we went here, the value of 1 is 25. The value of 2 is 42. It doesn't work. Okay? So again, a direct variation is a linear function, y equals k of x, where k does not equal 0. The other thing that you'll know about a direct variation is that it always passes through the origin 0, 0. Why? Because again, if the value of x is 0, 18 times 0 is 0. So it will always pass through 0, 0. If we graphed this equation, your origin would actually be 0, 7, not 0, 0. So y equals k times x. Okay, that is a direct variation equation. Now that we know what direct variation is, let's learn a few things that we can do with it. So we have a data table here. If we have a set of ordered pairs, that's an x-coordinate and a y-coordinate, we can write a direct variation equation based on these ordered pairs. So what do we know? We know that a direct variation equation looks like y equals k of x. Well, if y equals k of x, how do we find k? Well, we divide by x, divide by x. So k equals y divided by x. We need that in order to find our direct variation equation. So for example, if we have an ordered pair here, so let's say 3 and 15, we want to write a direct variation equation based on these ordered pairs. How do we do that? Well, we know our y value is 15, so 15 equals k times x. Okay, and what is our x value? 3. So k times 3. We want to know the value of k, so what do? Divide by 3, divide by 3, k equals 5. What can we do with that? Now we can say y equals 5 times x. This is our equation given that the value of x in an ordered pair is 3 and the value of y in an ordered pair is 15. Okay? If we plug these numbers into our equation, we should get the y value on the side. 5 times 4 is 20. 5 times 5 is 25. The other way that we can check is in any given direct variation, the k value is always the same. If it's not, then it's not a direct variation. How do we find the k value? Y divided by x. So we go over here. 15 divided by 3 is 5. 20 divided by 4 is 5. 25 divided by 5 is 5. Because this is true for all these values, we know our direct variation equation is y equals 5x. In a direct variation, the ratio y over x is a constant. So that means that in any given set of data, y divided by x will give you the same value. That means that y1 divided by x1 is the same as y2 divided by x2. This is important because we can use this information to solve proportions if we don't have all of the information from the proportion. What do I mean by that? Well, let's look at an example. If you're using a lever to lift weight, okay, there's a specific amount of force that you need to put on the lever to lift the weight. So, if we look at an example, say that we need 5 pounds of pressure to lift 50 pounds of weight. Okay? And we want to know how much pressure do we need to lift, let's say, 80 pounds. Okay, we don't know that answer. But what we do know is that the ratio of y divided by x is going to be the same no matter what. So, how do we set this up? Well, we know that the amount of force needed to lift 50 pounds is 5 over 50. So our x is 50 pounds, our y is 5 pounds. We want to find out how much does it take to lift 80 pounds. So 5 divided by 50, what is that value? 0.10. Okay? Now we can plug that back into our direct variation equation. What is our direct variation equation? It's y equals k times x, right? We have our k value here, which is the same as this, so we can plug it in. We want to know how much does it take to lift 80 pounds, okay? So our k is 0.10 and our x value is 80. So y equals 0.10 times 80. If we multiply that together, what do we get? 0.10 times 80 is equal to 8. So we now know that it takes 8 pounds of pressure to lift 80 pounds of weight in this lever.